Welcome back to Data-Driven Engineering. In this tutorial, we're going to talk about measurements, and in particular, how to access sensors, and then some of the implications of knowing how those sensors are collecting the data, helping us know how to cleanse the data and be able to use it in data-driven engineering applications. So we're going to do that with some microcontrollers. There are also microprocessors that are available, like Raspberry Pis. But we're going to focus on things like Arduinos and ESP32s, some of these microcontrollers that are really built for real-time measurement and just really have one function. They typically have lower memory, lower resources. They're a lot less expensive. They're easier to acquire as well. So this little ESP32 that we're going to show, that one is about $5 or so, $5 to $10 that you can buy online. And so we're going to use this little device right here, and I'll go ahead and show it to you. This I'll plug it from my computer. So here's a little ESP32, and it has Wi-Fi and Bluetooth that you can use to develop some type of Internet of Things, like an IoT device. And it already comes with the pins here, so it's very easy to connect. We're going to talk about how to connect this with an SPI interface and be able to measure something like temperature today. Okay, so let's go ahead and just configure this first of all. We're going to come down here. We're going to use MicroPython. You can also use processing. You can use the Arduino. They have a new interface for ESP32s. You can have Teensy boards, Raspberry Pi Picos, Arduinos, and others. But this is going to be MicroPython now, that we're going to run a simplified version of Python on this device. So you can't have things like pandas or, there's some packages that just don't have a version that's available for these little devices because they have lower memory and other things. So we're going to work with what we have and some packages that have been customized and designed so that we can run them on these little microcontrollers like the ESP32s. Okay, so you want to have the pinout here, schematic. That'll help you show what types of sensors you can attach and where you can attach them. The GPIOs, general purpose input output, those are the ones that we're going to typically use, but they're going to have things like the SPI SCK. There's our serial clock there, the master in, slave out, okay, master out, slave in. So these have multiple purposes on these pins, and we can configure them certain ways depending on the sensor that we want. All right, so let's talk about the first method. This is probably the easiest method, which is the Thonny MicroPython IDE. And you can come here and just download it to Windows, Mac, or Linux. And once you've downloaded that, we're going to go ahead and open it up. And if you don't have this installed yet, you might need this one as well. This is just a USB to UART bridge, these VCP drivers. So you might need to download and install this one if you don't see like a COM4 or something else come up that helps you connect to this device. Okay, so I'm going to first of all just go ahead and rotate this camera around just so we can see the device. Just position this down here just so we can watch what's happening with this little device as we work with it. Okay, so I'm going to just take this ESP32, and this USB is plugged into my computer, and I'll go ahead and just attach it. Okay, you should see a little LED start to blink once or twice, but then no more LEDs blinking here. Okay, so now what I'm going to do is just open up Thonny. So I've already downloaded that, and then I'm going to go to Run, and I'll select Select Interpreter, and then you want to select the one that you have. Okay, so the model of microcontroller, and so this one's going to be an ESP32. And then you want to select your port. Now again, you need that driver if you don't see something like this, like a COM4. So there's my COM4, and then I'm going to select Install or Upgrade Firmware. All right, and then I've got the COM4 right here. Now we need to go get the firmware for this device. So I have a link to that here as well. you can go to the ESP32 firmware, but depending on what device you have, you'll be able to go and grab that. I'll just get the latest one right here. These are the nightly builds, probably a little bit bleeding edge if you want some additional features, but these are going to be more of the stable versions. All right, and so it's shown that it's downloaded right there, and I'll just select that now when I browse for it. I'll go to my desktop, and there is my bin file. Okay, that's the firmware file. And then if I select install, I'm going to get an error. So what I need to do is just hold this button here onto the upper left side. That's the boot button. Here's the reset button. And the way that I found that this works is I just have to hold this down while I click install, and just leave it held down until I see it start to put the firmware on the device. Okay, so it's erasing the flash. Okay, now you can see it start to write. Now I'm just going to release that, and it should be able to finish all the way. But just hold that boot button down. I've tried before where I just touch the button and then release it, and it has an error that it can't connect. So I just hold that boot button down until it gets into this mode right here, and you can see it's writing the firmware. You can see little flashes occasionally just as it's going. All right, and then we're going to work on this later. We're going to install this thermocouple. All right, and I'll talk a little bit about some of these, this pinout here. It's a little hard to see. I'm not focusing quite right here. Okay, so it's going to have things like ground, VCC, SCK, CS, and SO. So let's just talk about those as it's going. What do those mean? So the ground is going to be just for the power, and the VCC, that's going to be a 3.3 volt. Okay, I'll make this just a little bit bigger so you can see chip select. So over the SPI interface, you have the option of having multiple devices. So the chip select is really, it helps you determine which device you're talking to. And then the SCK, that's an SPI clock. And then on some devices, you have MOSI or an MISO. And so that would be the thing that's really driving the master and is out, so it's communicating to the device, and the slave or the device itself is listening. All right, and then we have MISO, and that's a master in and the slave out. So the device is communicating something to the master. In this case, this little device that we have right here, this one is just going to be an SO because we don't have any master talking to it. So it's just going to be one, okay, one communication pathway for this. And here is just kind of a zoom in on the device. It's a little hard to see here. I'll make it just a little bit bigger. Okay, and this is our MAX 6675 board that's like a signal conditioner. And then we have a thermocouple here, this silver part. That's our thermocouple that you can measure temperature. So we're going to work on that. We're going to measure temperature with this device using this little board that we have, the ESP32. Okay, so it says it's all done, and I'll go ahead and close this and then click OK here. All right, so there it is. Here you can see now I have a terminal, so I can write my script up here in the top, and then down below that shows me that I have MicroPython 1.19.1, and there you can see the firmware date, and it's an ESP32 module with ESP32. So we can type commands here. So this is going to be print hello world. Okay. And there we go. I wrote my first Python command that's running directly there on the board. All right, but let's say I want to open up a file. I just come to this open folder, and where do you want to open from. You can either select this computer or the MicroPython device, and I'll go ahead and select MicroPython device. Now I have boot here. If I name something, if I name it main.py, it will execute after the boot. The boot will execute first, okay? And this file is executed on every boot. So right when the device turns on, it will run these commands. And you can see this is just commented out. These are just kind of placeholders here. But if I wanted to create a new file and then print hello world every time this thing starts up, I could include that in boot, or I can include that on the device as main.py. So this will run after boot. And then when I restart this, okay, then it will run that, but it didn't print it here to the terminal, but it did run this after the boot command. Okay, so now let's do something a little bit more. Instead of just this main.py, I'm going to create a new script here, and I'll just call this one, I'll save it to the MicroPython device, and I'm going to call this blink.py. Okay, so I've saved it here. I'm going to come back to our web page, and let's just have this blinking application that's right here. I'll click the get code. All right, and then come back to this interpreter. Okay, so I've saved this. Now I can run it right here, hitting F5, and you'll see now, I don't know if you can see the LED blinking there. Okay, so every half a second it turns it on or off, and you can see the device blinking right there. It's a little hard to see. Okay, so that one worked. We're running Python kind of indefinitely here on our device. Now I'm going to go ahead and stop it, and then if I select my interpreter and click OK, or what I have to do sometimes is to stop it if it's running indefinitely, I can hit this reset button. Okay, and that will start it up again, and then I'll see that I've got my Python command prompt back, and so it's ready to run something else. Okay, so let's go and do something just a little bit more now. We're going to come back to the web page, and this is our next activity here, where there's, you can either have a pressure sensor, and it shows some code here on how to get a pressure from this BMP 280 device. You have to load this library, or we can also do this this temperature using MicroPython. So I'll go and I'll make a new video on this as well, but let me just show that to you here in this video, just hooking it up. I'll give a little bit more details in this other video that I'll post to this site as well. But we're going to hook up our cables for our pins here, and then measure some temperatures. Okay, so here is going to be we're going to take 20 measurements using these pins right here. Okay, so I'm going to see if I can get this hooked up. So I'll go ahead and just unplug it, and then I have these pins already hooked up on this side, and I'll go ahead and plug in the white and the black. So those are going to be my power. Okay, and those are connected here to the VCC and the ground. So the very first thing that I need to do is just look at these very small characters here, and there is 3.3 volts right here. So I'm just going to connect it here for my white and my black, and then I need to connect the select, the CS. I'm going to connect that here to my G23. So the purple one, I'm going to connect that here to 23. And then I have two more that I need to connect, and I will connect the clock to pin 18. Okay, so that's going to be my gray one, is my clock. Let me see if I can find 18 here. Okay, there it is. And then I'm going to have my slave out. And we don't typically say slave out or master in, those, we're changing the terminology we use in the instrumentation and automation to be primary and secondary, okay, but instead of master and slave, but you'll still see that in a lot of the documentation, but that's changing. Okay, so I think I have it hooked up now to all of these for the SPI interface here, and I'll go ahead and plug this back in. Okay, there I go. I have it plugged in. It has the SPI interface cables set up so I can collect a temperature. All right, so I'll go ahead and just do a new one. And let's just save this code right here as, instead of here, I need to stop and then reconnect. Okay, so it's reconnected. And then if I click save now or Control S, it'll ask me. So I just needed to hit stop so that it would reconnect to the device, and then I see that it's ready down here at the bottom. Okay, so I want to save it on the MicroPython device, and I'm going to call this one temp.py. All right, and then I need to save one other thing. So this one is going to be basically my driver function. Okay, so here is my driver. I'm going to save this as Mac6675 and click get code. This is just a slightly modified version of the one that Ivan Sevchik posted. So thank you for providing that. There's a great community out there who share some of these files. Okay, and I'm going to save this, and I'll save that as max6675.py. Okay, so when I come back here to temp, now I'm going to be able to import that. And then I'm going to be able to connect to it. I already selected those pins. Here's my selector there. It's going to be device. The device is going to be, okay, chip select is going to be 23. This is the serial slave out. Okay, it's 19. And then there's my clock, which is 18. And I'm going to loop through this 20 times and just read temperatures. Okay, it looks like there's an unexpected indent here. Let me make sure I have that copied over correctly. Okay, it looks like it's something in this one. Let me go to line 45. Okay, it looks like there's a tab or something that I should have been using spaces instead. So I think I need to go through this. I'll post that new code there that doesn't use tabs, but uses spaces. And it looks like I just had an unexpected indent. Error there. Let me just check the rest of it. Looks good. Go ahead and save that one more time, and I'll save this, and I'll run it. All right, so there are my temperatures. I'll go ahead and just put my finger on this one. This one has a little bit of a mass to it, so it's going to increase in temperature. As you can see, I've just put my finger here on the edge of the thermocouple. Okay, so you can see some measurements that we've taken. We can, if we had a Bluetooth connection or Wi-Fi, or we can communicate over this serial connection, we can read that back into our system, be able to collect data about temperature. Okay, so that is all for this one. This is through Thani. I just did want to show one last thing though before we end this video. Sometimes you don't want to use Thani, you want to use the command line to load some of these, and so we can also pip install ESP tool, and so let me just show you how to do that as well. Okay, so if I close out Thani, and I'll just go to my desktop and then pip install ESP tool. sometimes you want to specify what Python version you're using. So I'll just do Python-M, and then it's going to go out and get the dependencies of that, and then install ESP tool. Okay, so it successfully installed that. And now I can do this first command to erase the flash. All right, so I have my device, and let me go ahead and just erase the flash on this device. I'm going to hit the button here. Okay, so it looked like it wasn't available. I think I'm on COM4 instead. Let me just change that. So make sure you just identify which port you're on. If you need help with that, just come to Device Manager, and then you go to Ports, and then you can find which port number it is. So that is COM4. So I just changed that to COM4. Let me try that again. I'm going to hold this down and hit Enter. Okay, so it's connecting, and it's erasing flash. It says it might take a little while. All right, so it says it's hard resetting. All right, now let's go ahead and just flash this firmware now. And what I'll need to do is just get the code here. All right, and then come back to my command prompt. Now this one is going to be just a little bit different because I have firmware.bin, but it's not firmware. It's if you just hit tab over, erase that, and then tab over, it'll eventually get to your bin, your firmware. Okay, so I'm going to go ahead and hit boot again because now I'm writing to it. So you always have to hit that little button in the upper left-hand corner when you're writing to it. Okay, so let's see, ESP tool. Okay, hold on, let me try this again. Oh, I need to get rid of the .py there. Okay, and I'll fix that in the command. Okay, so Python-M ESP tool, and then all of this. Oh, I hit the COM5 again. Okay, I had it in the command COM5. Let me try it one more time, just fixing some of these options. Okay. Okay, so here it goes. It's writing just like we had from Thani. Okay, I can go ahead and let go of that boot button now and let it go. It'll finish writing. It's a little bit faster than Thani, you know, so I'm going to go ahead and just edit this, get rid of the .py right here, and then just make sure you update your port. If you're on Mac OS or Linux, you can just search for something like in your dev, like TTY USB 0, or similar for Mac OS as well. Okay, so that's just how to install it with this method 2 command terminal with the ESP tool if you want to do that instead of use Thani. There are many other environments that you can use to program these. You can set it up in VS Code, you can set it up in other environments. I've just found that Thani is a very nice compact interpreter and IDE, integrated development environment, that helps you to develop some of these applications for very simple applications, just testing it out. Okay, you might want to use something a little bit more sophisticated if your project becomes a little bit more involved. Okay, well that's just a tutorial on some of these sensors. The next one is going to be about cloud, cloud computing, cloud storage, and we'll go through some of these as well with an activity to develop a cloud application. And then finally in this series we'll go to web scraping as well as just another source of information. But this sensors one that we talk about, the edge computing or other things like that, this is really having access to the sensors themselves and understanding them and knowing what they're producing so that we can cleanse and use them in our data-driven applications.